In today's video, we will be discussing the Hardy-Weinberg principle and the effects directional selection has on a once stable species with varying phenotypes and genotypes. To begin, we have three birds of the same species with varying beak sizes. Birds whose alleles are homozygous dominant have long beaks, while birds with heterozygous alleles have medium-sized beaks, and birds with homozygous recessive alleles have small beaks. In this population, there are 25 birds that are homozygous dominant, 50 that are heterozygous, and 25 that are homozygous recessive. Together, they all consume nectar as one of their food sources from tubular flowers that are available in all sizes fit for the varying beak sizes. Here we have a chart depicting the genotype frequencies in the population and the allele frequencies. To calculate the genotype frequencies, you simply do the number of individuals with a specific genotype divided by the total number of individuals in the population. To find the allele frequency for big A alleles, you do the number of big A alleles in the population divided by the total number of alleles expressed in the population. This is repeated in terms of the little a allele to find its allele frequency. Here we see that the allele frequency for big A alleles is 50% as well as for the little a alleles. Before discussing the effect of selection on this population, I want to discuss the Hardy-Weinberg principle and how it applies to frequencies found in the previous slide. In the Hardy-Weinberg equation, it is noted how the p variable codes for dominant allele frequency, while the q codes for recessive allele frequency. It also states that p squared is the frequency of individuals that are homozygous dominant, while q squared is the individuals that are homozygous recessive, and 2pq is the frequency of individuals that are heterozygous in the population. When applying the values found in the previous slide, we find that the equation equals 1, which is compliant with the Hardy-Weinberg equation. However, say that there is a flower shortage and only long tubular flowers are in great supply. This would violate the Hardy-Weinberg principles, for selection would have to occur, favoring the extreme where the homozygous dominant birds with longer beaks, because they can reach into the long tubular flowers better to consume nectar. This is known as a directional selection distribution. Directional selection refers to an environment favoring one extreme or a homozygous genotype over another. In this case, the heterozygous and homozygous recessive birds will be at a disadvantage, for their beaks will not be long enough to consume nectar as much as the homozygous dominant birds with longer beaks. So to discuss how this would mathematically affect the frequency of genotypes and alleles, we will analyze the following chart. The original genotype frequencies were 25%, 50%, and 25% for the homozygous dominant, heterozygous, and homozygous recessive genotypes respectively. But now we have to consider their relative fitness due to the selection that has been imposed on their population. The fitnesses are listed in the chart above. After using the frequency after selection equation, the frequency for dominant genotypes is 0.46, for heterozygous is 0.41, and for recessive it is 0.13. Using the new frequencies, the new dominant allele frequency increased and the heterozygous and recessive frequencies decreased. This affects the frequency of alleles. The frequency of the dominant allele increased to 0.67 while the frequency of the recessive allele decreased to 0.34. Therefore, the dominant phenotype now has the advantage over the other two phenotypes.